Hey guys, welcome to another video of single phase half wave rectifier. We are at first we will see the with freewheeling diode, that is a diode, a semi controlled rectifier. Then we would learn about RE load and then RLE and all this stuff. Freewheeling diode. What a freewheeling diode? When an anti-parallel diode is connected across load and when on when on short circuits the load so that current can flow freely through diode is called as freewheeling diode. That means the diode is connected opposite to the output of the rectifier, and it's like this. P is connected to the N negative side and the P side is connected to the positive side. That means it is, when it is forward bias it will become the reverse bias, and when it is for reverse bias it will become the forward bias. Forward bias, that means short, right? When D1 is open, like on, on, okay, when D1 is on, that means this is on. VO is equals to the uh, VO is equals to VS, obviously, and this become forward bias, so it become reverse bias, okay, and it become open. And the voltage develop is VFD and VOVS. VFD is equals to the, by using KVL we can say that, okay, this is minus VS by directly, directly we can say that, or minus VO. Always minus VO, it will be always minus VO because it is connected in opposite fashion to the VO. During positive cycle of VS, VS is greater than 0, VFD less than 0, reverse bias. Negative cycle, VS less than 0, VFD greater than 0, that means it becomes forward bias. Alright, and it helps in discharging also. We'll see that. Freewheeling diode. During positive half cycle, diode D1 is open on sorry VO equals to VS and VFD is minus VS. During negative half cycle, for freewheeling diode becomes on and VO becomes 0 because it becomes shorted, and it becomes VS VD1, okay, because it is off, so open circuit. Due to inductor present in load, conduction goes beyond pi and L takes time to discharge. As soon as conduction goes about pi, freewheeling diode turns on and short circuit the output. Got it? So see, in the normal RL circuit, what would happen? Due to the inductor, it will take time to discharge, so the extinction of current is beyond pi, that is beta is beyond pi, so takes time. But here, due to the freewheeling diode, beyond pi, freewheeling diode starts conducting and it would the output voltage will be 0. So the waveform that comes similar to that of the R load, like this. See, pi, after pi it becomes 0, because we know that after pi it becomes uh, open fueling diode on, yeah, on, so that the VO would become 0. That's why. And due to the inductor beta, after pi beta it would be the extinction. And when it is maximum at pi by 2 plus 5, pi by 2 plus 5. VD1 obviously when pi to when 0 to pi it is on, so it would be short, and other place it will follow the Vs or minus Vs, what, yes, Vs. And also VFD also follow Vs when it is open, and when it is on it would be short. Yeah. You have understood this, you have understood this, that fueling diode turned on at omega t goes to pi, and it remains on till current becomes 0, and omega at omega t uh, equals beta. Understood this. You have understood this, that fueling diode turned on at. Okay, so it will conduct pi to beta. That is what induction angle of T1 would be pi, and freewheeling diode would be beta minus pi, and PIV obviously VM. This is not a confusion to take on. Now the case one is that we are charging, yeah, so both are greater than 0 and ion is increasing, power is greater than 0, source to load. and inductor is charging. Got it? From pi by 2 to pi, it will be like both are greater than 0, but it is reducing, like I0 is reducing. So that means supplying like the supply is supplying, okay, source is supplying, and also the inductor is also discharging. Yeah, both source and inductor deliver power to R. And from pi to beta, you can see that it is I0 is decreasing, V0 is negative, so source is not supplying. Inductor discharges through R, like inductor is supplying the to the R. Without freewheeling diode, inductor discharges faster. Okay. So the discharging of inductor is faster without any freewheeling diode. What is the effect of freewheeling diode? Yeah. Okay. Okay. So the area of V0 is increasing. That means the negative part is vanished. So the area increased. That means V0 average is increased. Also the continuity of I0 increases because beta of freewheeling diode and RL load is more than that of the beta of only RL load. So the continuity of I0 increases because if it reaches 2 pi, yeah, that means again conduction starts, so it will become continuous like that. Okay, because beta is increasing, so beta when it reaches 2 pi, it will become continuous. That's all it want to say. Yeah. Uh-huh. Okay. Okay. So all this stuff you can read it pretty simple. That RMS is reducing because it is a square of, and all this related stuff also reduces and this increases. We can calculate the average pretty simply. Let me calculate it. V naught average. What would be 1 by 2 pi time period? V naught average. Yeah. So it is converting for 0 to pi. Yeah, 0 to pi. Vm sin omega t d omega t. 1 by 2 pi Vm by 2 pi, sorry, and sin omega t we can write it like sin omega t would be cos minus cos omega t by omega, sorry, d omega t, so omega t 0 to pi and Vm by 2 pi. Cos 0 is 1 and minus 1, so 2 I think. So Pm by pi would be our V naught average. Now you can calculate the RMS voltage also. 0 to pi Vm square sine square omega t d omega t, and we need 1 by 2 also. Yeah, so obviously we can get uh, Vm out. For we can set to 1 by pi 0 to pi sine square, we can write it like 1 by 2 1 minus cos 2 omega t d omega t. So it is clear. Iron average obviously we can calculate because inductor is short, so Vm by pi divided by R, and inductor cannot be shorted for AC component, that is RMS one. So for RMS we cannot short the inductor, that is why I naught RMS would be V naught RMS by R. Waveform of V naught is same as that of the R load, obviously we can see that. Now the RE load, pretty simple and nice. So for the RE load, we can short circuit test, that is D become short and current would be Vm sin omega t minus E by R, and if I greater than 0, that is on, and that means Vm sin omega t greater than E, and less than 0, that means Vm sin omega t less than E, that is off. So for, let's say, theta to pi minus theta, for theta to pi minus theta, the diode is on, so the current would be greater than 0, that means it would allow the current to pass through it. Okay. Okay, now determining the theta, we can determine the theta also when it is equals to E sin theta, sin inverse E by Vm. Not a very big deal to calculate theta. Diode remains on for omega t theta to pi minus theta. Yeah, when it is greater than E, like Vm sin omega t greater than E. Yeah. In this range it is on, that means short. Vs minus E by R, V naught is Vs. When diode is off, it is open circuit. VO would be E, and VD will be Vs minus E, and current would be 0, obviously. Now the waveform, make this E, make E, okay, and theta pi minus theta, 2 pi minus 0, 3 pi minus 0, okay. Let us draw this. Vs we make E, okay. Now theta pi minus theta, 2 pi minus theta, and 2 pi plus theta, and 3 pi minus theta. Got it. Now you can make the outline of like pi, 2 pi also needed, 3 pi also needed. This much we are drawing, okay. So it would be like this, and this. First make the outline, then make E. Can make E. Okay, now, okay, so see, the waveform is pretty simple. It is not a hard thing, but the concept is very important. If you see that for theta to pi minus theta, VO is equals to VS. It would be, when the diode is off, VO would be E. VO is E. Got it. So this is like this. Yeah. VO is E. Got it. Now if you want to get the I naught, also I naught is required. So I naught would be like see, it is 0 for when the diode is off. When diode is on, I naught will be Vs minus E by R. Okay. So for when it is on, it would be like Vs minus E by R. Okay, and it is when maximum Vm minus yeah, so we got Vs, we reduce it by E and divide by R. That is what is we are doing. Okay, and when it is 0, diode is off when it is 0. Want to know the VD? Here VD is 0. Yeah, and when it is off, VD is Vs minus E. So we know the Vs, we should shift it by E only. Draw the Vs and also the E and just drop it by what? E. Like E, it would come here, it would come here. Okay, it would come E plus E, and minus Vm plus minus E. Yeah, minus E, and that's all. IO goes to VO E by R.